Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about tangents and equation of a tangent. So we're going to see how we're going to use differentiation mechanisms or the mechanism we've learned in differentiation in the previous video to find the equation of a tangent and the tangent, okay? So before I proceed, please don't forget to like, share, and subscribe. And if you've not clicked the notification bell, I don't know what you're waiting for. Please do that. So when I post new videos, you'll be the first person to know. All right. So what are tangents? Tangents are lines that just touch a point on the curve and they have the same gradient. Okay. So for instance, if you have a particular curve and you have a line like this, so this line is said to be tangential to this curve. All right. So because I'm aware that some of you are writing, so what I'm going to do is that I'm going to try and write it down a bit, what I just said, so that it will be easy for you to take note. So what tangents, okay, are lines that just touch, okay? So these are lines that just touch. So as you can see, in this part, they just touch at this point. Are you seeing it? They just touch a point on the curve. And also, they have the same gradients. So a line that is tangential to a curve will have the same what? Gradient. All right, good. So what we are trying to do now is I want to see how we're going to use differentiation to find the gradient and the equation of a tangent. All right. So before you start or before you go further, I will usually advise for you to go back and review and remind yourself what the equation of a line. I've talked about the equation of the line, and I've talked about the different types of equation of a line. But the one I want you to focus on is the slope-intercept form, which was the y minus y1 is equal to mx minus x1. All right, so you can go back to the videos. I have a video on this, okay? So go back to the playlist and search for the equation of a line and try and remind yourself how to calculate the equation of a line. And also, I also told you as well that the slope for this is equal to y2 minus y1 divided by x2 minus x1. So we talked about this earlier. And also, try as much as possible to review all the differentiation mechanisms I've talked about in the previous video. So try and make sure you are conversant with, I think there are 15 of them. I showed you how to differentiate trigonometry, power rule with a constant, and the rest of it. So make sure you go back and make sure you know how to differentiate each and every one of them. Okay, so remind yourself about it. All right, so, but in this case now, we're talking about, we want to find the equation of a tangent. Okay, so now we're looking at equation of a tangent. How do you find the equation of a tangent? So equation of a tangent is given, I'll write down the equation now, of a tangent. So it's similar to the equation of a line, but in this case, you have y minus y1 is equal to, instead of you having m, because the last time you had m for equation of a line, but this time you're going to have mt x minus x1. All right, so this is it. This is the equation of a tangent, y minus y1 mt x minus x1. So where the mt means it's equal to the slope of the tangent. So the mt is the slope of the tangent, and this is the same thing as the y over what? The x. You need to remember this carefully, okay? So that is the mt is the slope of the tangent, and that is the same thing as the y over the x. So basically, the equation or the function you have or the curve you have, when you differentiate it, that is going to be equal to the mt, all right? So that is the reason why I said in the beginning that of this video that you have to go and review the mechanism of differentiation. So when you're asked to find the equation of a tangent, this is what they're asking you to do. They want you to write it in this form and then simplify. Then if they're asking you to find the slope of the tangent, so the slope of the tangent is basically trying to find the first derivative of the function. All right, so how do you do this? There are 5 rules, okay? So let's start solving. So there are 5 rules, or you can say 5 steps, okay? There are 5 rules or 5 steps on how to do this. So the first thing you have to do is that you have to substitute. Okay, so you have to substitute x1 into the original equation. To get what? y1. So you can see from the slope of the tangent, we have x1 and we have y1. So how do you get the y1? The original equation, you substitute x1 to give you the y1. Hence, so therefore, after you're done with that, so that must, at the end of the day, hence, you'll be having the coordinates. So you have, hence the coordinates, we having the x1 and the y1. So basically, the essence of step 1 is that you need to find the x1 and the y1. In some questions, the x1 and the y1 will be given to you. In some questions, you only have the x1, then you have to find the y1. Is that okay? Then after you're done with that, the next thing you have to do is that you have to then differentiate. So you have to differentiate the y equations. So the y equation that was given to you, all right, you have to differentiate it using any of the previously described differentiation mechanism of the previously discussed let's say described. That would make it. So any of the previously described differentiation mechanisms. Okay, so I've talked about the power rule. Power rule is a constant, how to differentiate trigonometry, how to differentiate natural logarithm, non-natural logarithm. So you have to differentiate, is it any of this? Okay, the essence of doing this is so that to get the y over dx. So because you know that when you differentiate, it's going to give you the y over dx, which is the mt. So which is the mt, okay? So that means the essence of differentiating is to get the dy over dx, and the dy over dx is the same thing as the what? The mt. Now, when you're done with that, the next thing as well is to get the value for mt, all right? So what you do, you then substitute x1 into the y over dx, or you can call it mt, anything you prefer, okay? So after you're done finding the dy over dx, the equation, then you now have to substitute xy into dy over dx to get mt, so as to get the value, so to get the value of mt. So to get the value of mt. Now, when you're done getting the value for mt, then you then substitute the value of mt and the coordinates from step 3 and step 1 into the equation of a tangent line equation. Is that okay? So then you then substitute the value of mt. So the value of mt is from step 3, okay? And the coordinates. So we got the coordinates from step 1. So you now substitute this into the line equation. Okay? So the equation of tangent, okay? And I told you that the equation of tangent is y minus y1 is equal to mt x minus x1. So you're going to substitute it into this. So because now you know the mt, okay? Now you know the coordinates, you know the x1 and the y1. Then after you're done, number 5, you then simplify. All right? So that's what you do. So So that means the very thing to keep in mind, you need to know how to find the dy over dx. Okay, it's important you know how to do that. Then you need to also know how to find the x1, y1 is very important. Then also when you're done, you then have to then substitute it into the equation of a tangent, which is y minus y1 mt x minus x1. All right, good. Okay, and also don't forget that the dy over dx is the same thing as the what? The mt. All right, don't forget that. So that means in order to find the equation of a tangent, you need to find the x1, y1. You need to find the mt. All right, so let's solve an example now, so that we can apply what we just learned. So let's pick this example I have here. So number one, they said find the equation of a tangent. Okay, find the equation of the tangent to the curve. We have it as y is equal to 3x cubed minus 2x squared plus 3x plus 8 at x as x is equal to 3. Okay, so you're told to find the equation of a tangent to this curve at x is equal to 3. All right. So let's go. Let's follow the rules and follow the steps and solve this question. So now, so remember I said in some questions, they'll give you both the x and the y. In some questions, they'll give you the x, then you have to find the y. So like in this, for example, you were given the x and the y was not given, all right? But in some cases, you could have the x and the y. So that means you have to just keep step 1. You just go straight to step 2. But in this case now, we have to find the y. So we'll have to substitute x1 into the original equation to get y1, hence the coordinates, okay? So we have to go back to find y1. So we have to substitute x into this. So we're going to have y will be equal to 3. Anywhere you see x, you put 3 in there. So it's going to be 3 cubed minus 2, 3 squared plus 3, 3 plus 8. And when you press your calculator for this, your answer is going to give you what? 80. So that means our x1 and our y1, we can now write it now to be the x1 is 3 and the y1 is what? 80. So we found the x1 and the what? y1. Are you seeing it? Now, the next step, step 2, we need to differentiate the equation using any of the previously described differentiation mechanism to get it. All right? So step 2, we then have to differentiate this to get the y over the x. All right. So we know that we have y is equal to 3x cubed minus 2x squared plus 3x plus 8. So we need to differentiate this. Okay. And this is the mechanism we're applying here is going to be how to differentiate polynomials. We've talked about this before. So that means to differentiate this now, the y over the x is going to give you what? When you differentiate this, it's going to give you 9x squared. We're going to use the power rule here and also follow the steps of differentiation of polynomials. Minus 4x plus what? 3. Okay? And that is that for that. But this is the derivative. But if you look at it as well, step 3, we need to get the value of mt. So that means it's very important to get the value of mt. And that is step 3. And step 3, we need to get the value of mt. And how do you do it? We're told that we have to substitute x1 into the dy over dx we got from step 2. Okay? So dy over dx from step 2. So from step 2, all right, to get the value of mt. So we're going to find to get the dy over dx, which is the same thing as what? Mt, all right, will be equal to, anywhere you see x, we're going to put 3, All right, so it's going to give us 9 into bracket 3 squared minus 4 into bracket 3 plus what? 3. And when you press your calculator, the MT, which is the same thing as the dy over dx, is going to give you what? 72. So as you can see, we found the x1, y1. Now we know the value for the MT. Now the next step is that after finding MT, we need to then substitute the value of MT from step 3 and also the coordinates into the equation of a tangent. All right, let's go. So step 3, okay, so now we're going to step 4 now, all right? So step 4, the equation of a tangent, or the equation of a tangent, y minus y1 is equal to mt x minus what? x1. We already know our mt is equal to what? The mt is 72. We know our x1 is what? 3, and our y1 is 80. x1 is 3, and our y1 is equal to 80. So basically, you then substitute it into this equation here. So you're going to have y minus 80 is equal to the mt, 72, x minus what? 3. We open the bracket. So remember, I told you that when you have single brackets, how do you open the bracket? It's going to be a times b. We give you ab. A times c. We give you what? ac. Are you seeing it? So it's going to become y minus 80 is equal to 72 times x. We give you 72x. 72 times 3 will give you minus 200 and what? 16. Then we take 80 to the other side. So we're going to give you, we're going to step 5 now, which is to what? Simplify. All right. So technically, I'm combining 4 and 5. All right. So I'm combining 4 and 5 together. So I'm going to take 80 to the other side. So we're going to have y is equal to 72x minus 216 plus what? 80. Then y is equal to 72x minus 216 plus 80 is going to give us minus 136. And this is the equation of the what? The tangent. All right? And that will give you that. All right, so that is that for that. So that is easy, just pretty straightforward. You substitute to get the x1, y1, then you differentiate it, you substitute x1 into this to get the value, and you put it into the equation, all right? And that will be that for that. So I want you to try these questions, okay? So you can go to the worksheet, go to the textbook, and try as much as possible, and you will see that we have loads of this, all right? So let's write this down. So if, for instance, we're told to find the equation, of the tangent. Okay, find the equation of the tangent. So they want you to now find the equation of a tangent at the point -1 and 2, okay, on the curve. They want you to find the equation of a tangent with the equation. So with the equation, y is equal to, or can you enter here? Yeah. So y is equal to 2x cubed plus 3x squared minus 2x plus 1. Okay. So I'm going to write it here again. So let me just write it here so you have to be more clearer. So let's write it here. So be y is equal to 2x cubed plus 3x squared minus 2x plus 1. All right. So that is it. So that is the equation of a tangent. So I find the equation of a tangent. Now, just a tip for you to keep in mind. The tip is that in this case here, all right, in this case here, you can see that both x1 and y1 was given. All right. All right. So you can see, you can find x1 and y1 were given. So you can see for this now, they gave you the x1 and y1, so you have to skip step 1 and go to step 2, 3, 4, and 5, okay? But in the second example, I'm going to give you exercise to try. You will see that step only x1 was given, then you have to find a y1. So it was find the equation of the tangent okay, to the curve. So y is equal to f of x when x is equal to 2, given f of x is equal to what? 4x cubed minus 4x squared plus 4x plus 4. So you can see now in this case, which is a little bit different, here only x1 was given. Are you seeing it? Only x1 was given. In the second one, you had both x1 and y1, but this one, you only have what? The x1. So I want you to try this, okay? Solve it and put your answer in the comment section so other students can also have a look, or other viewers can have a look. And if you're still struggling with it, you can have a chat with your friends to solve it. And if not, just send me an email, then we'll have a talk and a chat about it. I will solve it together. All right. And that'll be the end for this. Okay. So this is how to find the equation of a tangent. Okay, so what you do is that you have to first know the equation of a tangent formula is y minus y1 mt. So it's similar to the equation of a line, but this time instead of having m that you said it was y2 divided by y1, y2 minus y1 divided by x2 minus x1, but this time you're looking for mt, the dy over dx. So you're gonna, first thing you have to do, you have to find the coordinate, the x1 and y1. You differentiate the original equation, you substitute x1 to get the value of mt, then you now apply the substitute the value of the coordinates as well as the mt into the equation of a tangent. Then you have to then simplify and rearrange it in the form of y equals to mx plus c, or any of the equation of a line form. All right, and that is that for that. So the next one I'm going to talk about how do you find normal and the equation of a normal. All right. So don't forget to turn on the notification bell so that when I post the next video on normal and equation of a normal, you'll be the first person to know. All right. So I will see you soon in the next video.